Hello, I am Augusta with the matrix number of KIB 19004. So here's the detail of my other three group members. So there will be three purpose experiment. My other group members will be presenting this experiment. The first one will be presented by Anson, and the second one will be presented by Ramzan, and the third will be presented by Sohim. Here's an introduction about the medical devices that we're going to use, which is the oxygen concentrator. The oxygen concentrator is categorized into three parts, which is the oxygen concentrator itself, the humidifier, and its connecting tube. So what is an oxygen concentrator? Oxygen concentrator eliminates the nitrogen from the ambient air to produce 90 to 95 pure oxygen to offer it to the patient. An oxygen concentrator is utilized to deliver oxygen to people with breathing problems and lower oxygen levels such as cystic fibrosis and pneumonia. During this current COVID-19 pandemic, there is an increased demand of oxygen concentrator as the virus mainly attacks human lungs. So out of the 4 virtual visits of the medical department of UMMC, we were able to identify a clinical issue in NICU, pediatric department, which is the inconsistent delivery of fraction of inspired oxygen, FiO2, from oxygen concentrator. FiO2 percentage. FiO2 is a percentage or concentration of oxygen that a person inhales. Here's an article written by David Rabasky. He said that oxygen concentrator usually provide us 85 to 100% of FiO2. Nevertheless, the oxygen concentrator does not always perform as it should, as the speaker in the NICU department said. This is because in an unconventional places such as transport emergency van, the oxygen concentrator is not always applicable as the volume in the ambient air differs from places to places. From this experiment result, we hope to observe and understand the main causes that affect the delivery of FiO2. We seek to have better understanding of what may be improved and what condition to be taken account of. So here's the three hypotheses of the experiment. The first one is the larger the diameter, the higher the flow rate. The second experiment is oxygen concentration with the use of humidifier has a greater oxygen level than without humidifier, but there will only be a small difference between them. The third is as the environmental temperature decreases, the oxygen concentration level increases.
Hi, this is Anson, KIB 1900504, and I'll be presenting about our first experiment, which is about the effect of different diameter of connecting tube to the flow rate of oxygen concentrator. The problem statement is, does the diameter of the connecting tube affect the accuracy of the flow rate of the oxygen being supplied to the patient? What if we change the diameter of the connecting tube into a bigger diameter? Does it cause the flow rate to increase, decrease, or unchanged? The objective of this experiment is to investigate the effect of diameter of the connecting tube towards the accuracy of the flow rate of the oxygen being supplied from the oxygen concentrator. Poiseuille's law is applied in this experiment, and Poiseuille's law states that the flow rate of fluid through a capillary tube catheter is related to a few factors, which are the viscosity of the fluid, the pressure gradient across the tubing, the length and diameter of the tubing. The relationship is shown as the formula below. Q equals to pi p r to the power of 4 over 8 nL, where Q is the flow rate, P is the pressure, R is the radius, N is the fluid viscosity, and L is the length of tubing. After rearranging this formula, we can get the relationship between the airway resistance to the diameter of the airway. The formula for this relationship is shown as R equals to 8nL over pi r to the power of 4, where R equals to the airway resistance as the rest is the same as the previous one. There are some few assumptions to be made when applying Poiseuille's law. The assumptions are the viscosity of the fluid stays the same. In our experiment, we are using oxygen as the fluid, and its viscosity is 1.96. The length of the tubing stays the same. In our experiment, we are using 100 millimeters. The flow of the fluid is laminar, which means it is not too fast, which may cause turbulent flow. The fluid is incompressible, which means its density will stay the same. Moving on to our apparatus and materials, we will be using an oxygen concentrator, a connecting tubes with different diameters, transparent tube to form the T-tube, which will be shown later, a parafilm styrofoam ball, gauze bandage, an adjustable knife, a permanent marker pen, and tissue paper. Moving on to the procedural part. The first step is a 100mm transparent tube is cut and a small hole is cut in the middle of one transparent tube. A gauze bandage is placed on the hole and it is secured using parafilm tape. A tissue paper is placed on one end of the transparent tube and it is secured using parafilm tube. Another transparent tube is placed on the middle hole that is cut on the first tube to form a T-shaped transparent tube combined. Parafilm tape is used to secure both tubes together and make sure it is airtight. A small ball is put into the second tube and a tissue paper is placed on the end of the second tube to make sure that the ball doesn't fly out of the tube when the experiment is carried out. This is how the T-tube is going to look like. Oxygen will be flowing from the right to the left and the ball will be placed on the vertical tube. So when the oxygen is passed through the tube, the ball will be floating. The T-shaped tube is then connected to the oxygen concentrator without going through any of the connecting tubes. The oxygen concentrator flow rate is set to be 1 liter per minute. The height of where the ball is flowing is observed and is marked on the transparent tube using a marker pen as 1 liter per minute. Step 7 is repeated by changing the flow rate of the oxygen concentrator to 2 liter per minute, 3 liter per minute, 4 liter per minute, and 5 liter per minute. So on the vertical tube, there will be 5 markings. Steps 6 to 8 are repeated by inserting the original connecting tube from the oxygen concentrator with a diameter of 5 mm in between the oxygen concentrator and the T-shaped tube. Step 9 is repeated by changing the diameter of the connecting tube to 7 mm and 13.5 mm. This is how our diagram of the setup will look like. As you can see, the oxygen is flowing from the oxygen concentrator through a connecting tube and into the T-tube that we made. The ball is placed at the top tube. By changing the diameter of the connecting tube, we can observe the position of the ball in the tube. Next, move to our expected outcome. As we are using 3 different connecting tubes with different diameters of 5 mm, 7 mm, and 13.5 mm, the flow rate of the oxygen in these tubes are expected to be different. The larger the diameter of the connecting tube, the lower the air resistance and thus the higher the flow rate, according to Poiseuille's law. The effect of increasing the diameter is expected to have a huge impact on the flow rate. Doubling the diameter of the connecting tube increases the flow rate by 16-fold because according to Poiseuille's law, the formula states that R is to the power of 4. This outcome can be expected provided that the viscosity of oxygen gas stays at 1.96, the length of the connecting tube is fixed at 100 mm, and the flow rate of the oxygen gas in the tube is laminar, which means it's not too fast. That's all from me. Thank you.
Hi, my name is Ramzan Alisani, KIB 190062, and I'm going to present regarding experiment 2, which is effect of humidity to the oxygen concentration of oxygen concentrator. So firstly, the introduction. The problem statement of our experiment is, does humidity affect the accuracy of oxygen concentration level of the oxygen concentrator being supplied to the patient? And the objective is, we want to investigate the oxygen concentration level which is being supplied in different humidity condition. It's basically just using the humidifier provided by the oxygen concentrator and without using the humidifier provided. So using a galvanized cell set up as oxygen analyzer circuit. As we know that an oxygen analyzer can be made up of many different mechanisms, and one of the mechanisms that we can think of and is able to set up in our lab is the galvanic cell. So using this galvanic cell, we can generate an electrical current that is proportional to the oxygen concentration. So by the value of current that we got, that will be our indicator for the oxygen concentration level, since we cannot get our hand on an actual oxygen analyzer. So for the methodology, firstly about the apparatus and material. These are the apparatus and material that we use, which is the oxygen concentrator, connecting tube, humidifier, potassium chloride, platinum electrode, and also carbon electrode. And then we use multimeter to check the current, the beaker, and weighing scale. Okay, these are the procedure, which is also being written on our report, but generally, basically we will use the KCl solution, which is diluted into a distilled water. The concentration is being measured using necessary chemical balance reaction, and then we will soak both the cathode and anode that we use platinum electrode and also pencil lead as an anti-electrode, so the reaction will be stable, and then we will pass through the oxygen tube, which is connected to our oxygen concentrator inside the beaker, so the oxygen will be supplied inside our beaker, so the reaction will be there, and then we will made up our circuit using a dry cell, and then connect it to our galvanic cell, and we will measure the current from there. So that is basically how we set up our uh, experiment, and how we measure our parameter is by using the multimeter, which is measuring the current of the circuit that we have set up. So there are only two conditions here that I mentioned earlier. Firstly, by using the humidifier, and secondly, without using the humidifier. See, this is the setup diagram, as you can see, by using the humidifier and without humidifier. And from this experiment, the expected outcome is that we expect that the humidifier shouldn't be affecting that much of oxygen level, since we know that the usage of humidifier is not necessary, but it is suggested to avoid dry throat and all for the patients, because the direct oxygen source can be drying to the patient. So this is a little bit difference in humidifying level shouldn't affect the oxygen concentration level. So we expect there is not much difference between these two setups. So that's all from me. Thank you.
Hello, my name is Hayam An, matrix number KIB190702, and now I will be presenting on our experiment 3, the effect of environment temperature on the concentration of oxygen supplied by oxygen concentrator. So as an introduction, our problem statement will be, does the environment temperature affect the accuracy of oxygen concentration level of the oxygen concentrator or not? And the objective is to investigate if the oxygen concentration level change with the difference in environmental temperature. So we'll be using the same galvanic cell setup as oxygen analyzer circuit, as same as experiment 2. And this is the equation. So next is for methodology. So this is the material that we're going to use. Firstly is oxygen concentrator that will be supplying oxygen, and connecting tube, and hot plate for the warming the water. We have potassium chloride, platinum electrode, and carbon electrode for our galvanic cell setup. We'll be using multimeter to measure the current change, and beaker where we're gonna submerge the connecting tube. We have the thermometer to measure the temperature of water. Next, procedure. So, galvanic cell setup will be same as experiment 2, and to manipulate the temperature inside the beaker, the connecting tube will be submerged in a water beaker. And firstly, we will pour cold water into the beaker to obtain 16 degrees Celsius. And to maintain constant temperature, we're going to refill the cold water whenever temperature increase. And next, then we will be turning on the oxygen concentrator to supply oxygen into the galvanic cell setup. We measure the current from galvanizer setup and record. Then the water inside the beaker is heated up to a temperature of 25 degrees Celsius, which is commonly known like room temperature, and 32 degrees Celsius, which is a common hot temperature, average temperature in Malaysia, and 40 degrees Celsius, which is hottest temperature in Malaysia, accordingly using hot plate. Steps 3 to 4 will be repeated, and then after we got all the recorded result, then we will be comparing and observing if there is any change of the oxygen concentration level with changing the temperature. So this is a diagram. So we got the galvanizer setup, same as experiment 2, like here, and we got the Bunsen burner here, but actually we're gonna use the hot plate and beaker upon that. So the connecting tube here will be submerged inside the beaker. So expecting outcome. So in theoretically, as the environment temperature decreases, oxygen density will increase, which also means the oxygen concentration level will increase. However, since the oxygen concentrator is made up to be used in many different circumstances, a small change in the temperature should not cause a big change in the oxygen concentration level. Therefore, oxygen concentration level will slightly increase as the temperature decreases, but not in a large scale. So that's all for us. Thank you.